with Tavas Gupta and Malesh Pai, who are sitting right there, who work with me at Special Mechanisms Group, and Malesh is also a professor at Rice. The story of this paper is when I was first getting into MEV, kind of the start of this year, I heard a very surprising fact, which was that Jane Street was building 5% of Ethereum blocks, which is kind of startling if you think about it. A high-frequency trading firm, a very sophisticated one at that, was deciding whether your transaction was at the top of the block or at the bottom of the block or after their transaction or before their transaction. So I figured we should kind of investigate, like, why are they doing this? How are they doing this, given that they don't run any validators? And the answer to that second question is the system called proposer-builder separation, which you may have heard about yesterday from Casper's talk, but basically every 12 seconds in the Ethereum protocol, there's a new block produced. And nominally, we're supposed to select a validator to do that. But the validators aren't very good at proposing blocks. They can actually make more money by selling the right to propose blocks to builders. And that's what's called proposer-builder separation. So we have this auction that happens every 12 seconds. The implementation is called MEV Boost by Flashbots. And it's this open English outcry auction, which is kind of cool because we get to see the bids come in right away. Here's an example of that. On, I guess, your right side, you'll see the bids coming in. On the left side, I chose this block because the price of Ethereum changed a bunch on the centralized exchange during these 12 seconds. This is live, by the way. This is like actually happened all in 12 seconds. The price moved from like 1955 to 1990 almost in the span of 12 seconds. So what does that tell you? On Uniswap, the price is 1955. On Binance, the price is 1995. So there's a massive arbitrage available. The reason, the answer to that question, why does Jane Street want to build blocks, is because building the block gives you the right to capture that arbitrage, gives you the right to put your transactions first before anyone else and capture the arbitrage. So this block actually wasn't built by Jane Street. It was built by a different builder, Beaver Build, which is also an HFT builder. And you can see, if we go look at this block, the first 36 transactions were very clearly arbitrage transactions. And just taking a look at the first one, you can see they traded in massive size. This is not hedgeable right away. This is kind of $4.25, $4.3 million worth of ETH that they bought, which of course was cheaper on chain than it was on Binance, so there was an arbitrage available. And you can get an idea of how much profit there was from this by looking at the builder payment that they made, around $30,000 in one trade. So what's been happening, let me play this because it's a bit long. But when we first started PBS after the merge, basically all the builders were neutral, which means they weren't trading. They weren't Jane Street. They were just some infrastructure provider running a builder like Flashbots, right? And then we started to see Beaver Build come up, which is the one who won the block I just showed you. Manta, which is Jane Street's builder. Rsync, another high-frequency trading builder. And you can see as we start to get to the point where we're at now, these high-frequency trading builders are winning a lot of blocks. And yesterday, which was a very volatile day, they won like 70% of blocks. So just those two. So how do we identify whether somebody is an HFT builder? So I want you to take a look at the top left square of the kind of bottom square here. That's the bot AX69. And this is Beaver Build. And you notice that that bot only lands transactions in Beaver Build blocks. That's because it's their bot. They're the trading firm. They run the bot. And they run Beaver Build. And if I play this again, I want you to take a look right around here. You're going to see Rsync turn on trading right at the end, and you're going to see a very bright dot for Rsync towards the bottom coming on in the last couple seconds. Right there. And then there's another one called Builder that's a bit smaller. So we have about 3 right now, and a fourth one that's very small that's kind of irrelevant. So that's kind of how we identify them, is we kind of look at this correlation plot, and we look at whether a builder, a bot is very commonly trading with one builder. And that's a pretty good sign that that's run by the same builder. And then, of course, we have kind of the rumor mill and the Telegram group chats that kind of can confirm these things as well. So what we wanted to do is we wanted to kind of take a little bit more rigorous approach and make sure that this is something that is not just the most volatile days, the most volatile blocks, but something that's really affecting things more at a kind of observable level that shows up in the statistics. So we looked at all the blocks and we collected some data from Binance on the mid price of ETH/USDC. And we looked at how much that price changed over the previous 12 seconds. If it changes a lot, like in the block I showed you, there should be a lot of arbitrage. We should expect Beaver or rsync or somebody else who's an HFT trader to win. If it doesn't change very much, we might expect somebody else to win. And what a surprise. This is exactly what we saw. We fit a logistic regression. We kind of tagged the HFT builders that we knew about. And if you kind of follow these coefficients according to the model, when the price didn't change at all, the probability that an HFT builder won was 30%. When it moved 1%, which is like the block we saw, then the probability that the builder won was almost 80%. And then we ran a similar regression to see, and we broke it out by builder. One thing you'll notice is that Manta, which was Jane Street, has the highest coefficient here because they're really good. No, actually because there's some other strategies that the other HFT builders will do that Manta wasn't doing, probably from a regulatory appetite thing. So they were basically only focusing on this strategy, and that's why you see such a strong coefficient for them. So this now brings me to the second point of the paper, which is, now that we know this, what does this mean for the future of block building? One point that I want to emphasize is that in PBS, just because of the way it's designed, when you buy the block, you buy the whole block. And so if you're like Jane Street and you're good at top of block, but not good at the rest of the block, then that kind of puts you at a disadvantage. So what you really want to be is good at everywhere in the block. And the top of block, we already saw what you need, which is basically a prop shop. But for the rest of the block, you need private order flow. And the question is, what is these, as we see private order flow evolving, which is now about 25% of transactions on chain are private, which means they don't go to the mempool before they land on chain. What is that going to do to centralization? So here's a thought experiment as we think about this. So let's say there's kind of two spots in the block. You have the top of the block and the rest of the block. And builder A is, I don't know, these guys are Jane Street, and builder B is Flashbots accepting external bundles from a bunch of other trading firms. So builder A is better at the top of the block, okay? And the rest of the block, all the transactions are in the public mempool, so both of them have them, right? So what are the payoffs here? Well, builder A is going to build a block which is worth 45. Builder B is going to build a block which is worth 40. And under kind of idealized assumptions about the efficiency of the auction, builder A is going to pay 40 for the block to the proposer. So the proposer is going to get 40, and builder A is going to get $5. Okay. Now let's think about what happens in a similar setting when the transactions are not sold, or are sold in an order flow auction. They're not publicly available to everyone. So I have this OFA win binary variable, which says, okay, if you win the OFA, you get 20. So how do we think about kind of the profits here? Let's do the backwards induction. So you have, if builder A wins the OFA, then they will have a block that's worth 45, and builder B will have a block that's worth 20. So they will make 25. If builder B wins the OFA, they will have a block that's worth 40, and builder A will have a block that's worth 25. So it will be worth 15 to them. So what does that mean? It's 15 for builder B to win the OFA, and 25 for builder A to win the OFA. So builder A is going to win it for 15. And you can see the payoffs here. Now builder A's payoff is 10 before it was 5. Builder B still doesn't win anything, so their payoff is 0. The proposer now has only 20 when they had 40 before, and now the users get 15. But I think another question is, what does this do to the share of block building? So we kind of extended this model. We said, what if the opportunity at the top of the block is stochastic? So you don't always win if you're better, but you win more often. So we said, let both bidders draw their top of block value from an exponential distribution, but let one of them have a slightly higher exponential parameter. So they're going to be advantaged, but not win every time. So I suggest you take a look at the paper for more details on how the math works out. But if you want some intuition, basically, the advantaged builder is willing to pay more in the OFA for the same reason we saw in our example, even though it's stochastic. So now they win the OFA. And that VT term, which you can see here, is going to make them win a lot more, even with a slight advantage in the top of block. And you can kind of see that here. Just I would direct your attention over to this area, which is so this is lambda A over lambda A plus lambda B. So when lambda A equals lambda B, this is 0.5. So as you get a slight advantage, a very slight advantage, you immediately have a huge increase in the probability of winning for the advantaged builder under an OFA versus under public mempool. And then you can see a similar huge increase in the profit, even with a very slight advantage in the exponential parameter. So what should we do about it? Because private order flow is coming, right? There's no way we can stop it. So we have to adjust PBS, basically. The solution that we suggested in the final paragraph of the paper was to unbundle PBS. So instead of selling the whole block together, sell the top of block and the rest of block separately. And then, so we presented that in Paris, and then shortly after, Barnaby came out with kind of a very practical first step towards doing this, which was he called it Pepsi Boost. And basically you auction off the right to touch the UniV3 5 basis point pool, which is kind of that first pool we saw. It's the deepest pool and the most arbitrage pool on Ethereum, and sell that separately and then sell the rest of the block as normal. And then Bharath recently tweeted at me, and he was like, hey, we came up with this and we just built it. He's a Ethereum protocol fellow this year, which was pretty cool. So you guys can check that out there. So in summary, HFT builders build blocks because they want to capture arbitrage. And if you're better at the top of the block, you can pay more for private order flow, which could lead to centralization, because not only are you now good at the top of the block, but you're good at the rest of the block. And then we see a day like yesterday where you're winning 70, 75% with two high-frequency trading firms. And so the third thing is, if you want to fix this, you're not going to fix it by running a good OFA. You're not going to fix it by doing anything. You have to fix it as a problem with PBS, because the problem is that PBS is selling the whole block together. And finally, I saw some posts on People's Talks yesterday about looking for PhD internships. So we're actually hosting an internship. So come talk to me or Malesh, who's presenting in this session as well, and see what's up. We have a lot of cool stuff. We may not have Tim Roughgarden, but we do have half of Ethereum transactions. So cool. I guess I have like 1 more minute. So let me just say, like, another thing that you can do in the OFA design is that you want to push the OFA to be as close as possible to the end of the slot, because then there's less volatility, there's less advantage left in the top of block arbitrage game. And so if you push it really close to the end of the block, then you can kind of try to mitigate this, but it's still going to exist, obviously, because there's only so much you can do. You have to give the builders time to have their transactions. Cool.
So, yeah.
Hey, Max, great presentation. Big fan of the work you guys do at Special Mac. Question for you. Where do you see the market going as we have more RFQs and things like Dutch auctions come online with Uniswap X? How do you see integrated searcher builders either dominating, adding to their dominance in the market, or potentially regressing, or is this some kind of equilibrium we're going to be in for some time?
Yeah, so this is a great question. So there's a couple events recently that maybe suggested some things. I'll talk about one of them, which doesn't relate to me. And that one is Uniswap X turned on. They were doing opt-in for Uniswap X, which is their RFQ system, and now they're doing opt-out. And coinciding with that was the announcement that the firms that run Beaver Build and rsync, which are the two largest HFT builders, were going to enter that market. So I think it's very clear that those guys are going to play in those markets and that it's going to matter a lot. And that I think last year at ETHCC, or I guess it's this year still at ETHCC, there was kind of a consensus that by that time next year, we would be in a very different situation with regards to private order flow. And I think that's very true. Which means we need to start preparing PBS now because it's potential to be dystopia if we don't fix it. Yeah.